Hello everyone, I hope everybody is fine and ready to learn about quadratic relations. We want to talk about a factored form of a quadratic relation. I think by now you have learned about the standard form of a quadratic relation, which is the form where the equation is y equals ax squared plus bx plus c, and a cannot equal to 0, of course. A, b, c are real numbers. And we call this standard form. But now today we want to talk about another form of a quadratic relation called factored form. So the equation is y equals a times x minus r times x minus s. So the a is very clear. The a is the same coefficient as it was in standard form. But you may wonder what r and s stand for. So r and s stand for the x-intercepts of the parabola, or the x-intercepts of the graph of the quadratic relation. So R and S stand for x-intercepts. We also call them the zeros of the relation, as you very well know. Zeros of the relation is the same as the x-intercepts of the graph. And in standard form, if you recall, the c value was actually the y-intercept. So each form has its own advantages. The advantage of the standard form is that you can quickly, and by just looking at the equation of the quadratic relation without touching a pencil, tell what the y-intercept is by looking at the c value. And the advantage of the factored form is that you can tell what the x-intercepts of the parabola are without even touching a pencil by just looking at the equation. I can give you a numerical example. Y equals 2 times x minus 1 times x plus 7, for example. When you look at this equation, you can easily tell that the value of r is equal to 1 and the value of s is equal to negative 7. So this means that the x-intercepts of this parabola are 1 and negative 7. The value of a is, of course, 2. And because it is positive, we know that this parabola opens upwards and the vertex is a minimum. In case of standard form, I can give you an example. Y equals 3x squared minus 6x plus 5. By just looking at the equation, you can identify the value of c, which is 5. So you can easily say that the y-intercept of this parabola, which is the point where the graph intersects the y-axis, is equal to 5. And you see that no calculation is required. Now, you may say, what is the advantage of knowing the x-intercepts? Well, if you think about it, if you have a parabola like this opening upwards, and if this plays the role of the x-axis, and if you have these two x-intercepts, we call them r and s, for example. Because a parabola is a symmetrical U-shaped graph, R and S are images of one another with respect to the axis of symmetry. Axis of symmetry is a vertical line that cuts the parabola in half, and it is passing through the vertex. So it is a vertical line that is drawn right in the middle of the parabola. It's called axis of symmetry. Okay. Now, the vertex is on this axis of symmetry, and it's exactly in between, midway between the two x-intercepts. So logic dictates that the x-coordinate of the vertex must be the average of the x-intercepts. So if you want to find the x-coordinate of the vertex, you can just grab the r value and s value, add them up, and divide it by 2. This is how you find the average of two values. Add them up, divided by 2. So if you know that r is, let's say, 4 and s is equal to 6, then by finding the average of 4 and 6, which is 4 plus 6 divided by 2, that is 5, you can easily say that the x-coordinate of the vertex is actually equal to 5. And if you have the equation of the parabola, you can plug in this x-coordinate of the vertex in the equation, and you can calculate the y value of the vertex as well. So it's not a bad formula to remember. that the x-coordinate of the vertex is always found by finding the average of the two x-intercepts. So it's r plus s divided by 2. We have an example here. It says given the x-intercepts of r of 4 and 0 for a given quadratic relation and the vertex of a parabola at v 2 comma negative 12, find the equation of the relation in standard form. So because the x-intercepts are given in this exercise, we will start from the factored form, logically speaking. So we're going to say y equals a times x minus r times x minus s. We're going to write the very first line, which is writing the factored form of the quadratic relation. And then instead of values of r and s, we are going to plug in 4 and 0 because we know that the x-intercepts are 4 and 0. So we end up with x minus 4 times x minus 0. The value of a we do not know. Therefore, it remains unchanged. So if I just simplify this, I'll get y equals ax times x minus 4. Now, we don't know the value of a, but instead we do know that the vertex of the parabola is at 2 comma negative 12. Because the vertex is a point on the parabola, therefore its coordinates should satisfy the equation of the parabola. That means that instead of y, I can plug in negative 12, and instead of x, I can plug in 2, and I can claim that left side equals right side. So a times 2 times 2 minus 4 on the right side should equal to negative 12, because the coordinates of the vertex must satisfy the equation of the parabola. If we had a point which was not on the parabola and it was off the parabola, I would never say that the coordinates of that point should satisfy the equation of the parabola. But now I do say that because we know that the vertex is actually on the parabola and not off the parabola. So doing the math here, I think we get negative 4a equals negative 12. Dividing both sides by negative 4, we end up with a equals positive 3. So we found the value of 3 because we did know the coordinates of the vertex and we did know the two x-intercepts. Now we can substitute back in the original equation. So y equals, instead of a, I plug in just 3. I sub it back in the equation I had before. 3 times x minus 4. So this is the equation of the quadratic relation in factored form. But we always have to read the question very carefully. It says give the answer in standard form. So now I have to do a conversion here, converting from factored form into standard form. How do you do this? By simply using distributive law or by expanding. So we get y equals 3x squared minus 12x, right? And this is, of course, the final answer in standard form. What are the values of a, b, c? Well, a is equal to 3. The value of b is negative 12. That is the coefficient of x. And c, of course, is equal to 0, which tells us that the y-intercept of this parabola is actually 0, meaning that the parabola passes through the origin, in other words. So we were supposed to write the equation of the relation in standard form, and we did write it. In the next example, it says write the equation in factored form given the table of values. When you look at the table of values, you may immediately notice that when x is negative 3, y is 0, and when x is 1, again, y is 0. What does that tell you? It tells you that if x is 1 or negative 3, the value of y is 0. And this is actually showing the zeros of the relation, or in other words, x-intercepts of the parabola. So basically, r is equal to negative 3 and s is equal to 1. And we can get this information from the table of values very simply. Okay, so we may write the equation as y equals a times x minus r times x minus s. We don't know the value of a, but we know that r is negative 3, so x plus 3, and s is 1, so x minus 1. this much we can write so far. In order to find the value of A, we need a point on the parabola. And there is no shortage of points here. Look at all these points that we do have in the table of values. All of these points are on the parabola. I can select any of these points, okay? And I can plug these x, y values in the equation, and I can claim that left side must equal to right side for an obvious reason. And the reason is because these points are lying on the parabola. So I can select any point. For example, I can select 2 and 10, all right? Let's see. If I plug in 10 for y, and if I plug in 2 for x, let's see what we will end up with. So here I get 5a equals 10, and if I divide both sides by 5, I get a equals 2. Back substitution gives me y equals 2 times x plus 3 times x minus 3, which is the equation of this parabola. It is in factored form, needless to say. Now, if you wonder where the vertex is, it's not that difficult to find the vertex. I would say the vertex is located at a point where the x-intercept, where the x-coordinate is the average of the x-intercepts. So I mentioned the formula before. I put in a bubble at the top. So I'm going to say the x-coordinate of the vertex is actually r plus s divided by 2, which is 1 minus 3 divided by 2, and that is -1. So the x-coordinate of the vertex is 81. And here we already had this point actually in our table of values. We didn't know that is the vertex. Now we do know that it must be the vertex because the x-coordinate of the vertex is 81. So this point, 81, 88, was actually the vertex. We did not know before, now we do know. So the vertex is located at -1, -8. Even if we didn't have this table of values, we could simply plug in 81 for x in the right-hand side of this equation, and we could simply calculate the value of y, which would be -8 again. Imagine this is -1 minus 1, that's -2. This will be +2. Multiply them, -4 times 2, -8, same answer. So we could have calculated the value of y by ourselves using the equation that we just derived. Okay, so why don't we try to actually sketch this parabola. We know the x-intercepts are at 1 and -3. So -3 is right here, 1 is right there. And -1, -8, that is somewhere here. And I can just draw a sketch of this quickly because we have the vertex and we have the x-intercepts. So it may not be extremely accurate graph, but it is a pretty accurate sketch of it. The parabola opens upwards. The vertex clearly is at -1, -8. The axis of symmetry is passing through the vertex. Therefore, its equation is x equals -1. I label the vertical line representing the axis of symmetry, and the parabola itself can also be labeled with its equation in factored form, which is 2 times x plus 3 times x minus 1. If we want to expand these two binomials and collect like terms, we can also convert this into standard form if necessary, if required. But here, we don't need to do that. So we see that there are useful forms of quadratic relations that can be used to solve a variety of problems. These forms are factored form and standard form. There's another form called the vertex form, which extensively we have talked about in the past, or we will talk about it in future. But there's, generally speaking, 3 forms for a quadratic relation: factored form, standard form, and vertex form. In this lecture, we focused on only 2 of them, that is standard form and factored form. Okay, I hope you understood how we solve a variety of questions using factored form. And now it's your time to practice and keep studying in order to be successful. Thank you for your attention.